Today we're leveling up your engineering toolbox. Top trending open source GitHub projects this week. Part 2 is here, showcasing groundbreaking advancements in performance and accessibility. We'll detail 10 critical projects, starting with Spring AI Alibaba, bringing graph-based multi-agent systems to the enterprise-ready Java ecosystem. We will also examine OpenArm, a powerful 7-degree of freedom humanoid arm designed for contact-rich AI research, and LangChain.js, the web-native gateway for orchestrating complex LLM agents and tools. Let's start the step-by-step deep dive.
Welcome back to Manu AGI Tutorials. Here, we explore the exciting world of AI, latest AI tools for you, so don't forget to hit that subscribe button and the notification bell so you don't miss out on the latest AI insights. So let's start today's video.
Project number 1, Spring AI Alibaba, agentic AI framework for Java. Spring AI Alibaba shines because it brings full agent and workflow capabilities into the Java/Spring world in a way that feels native yet powerful. Instead of treating AI as just an add-on, this tool turns AI into a first-class part of applications, letting developers build chatbots, multi-agent systems, and orchestrated workflows without wrestling with plumbing. One of its most unique features is its graph-based multi-agent framework. With this, you can define agents and workflows in a graph structure. Agents talk, make decisions, coordinate, branch, and even include human approval steps. It supports nested and parallel flows, memory, state snapshots, and streaming, all packaged in a visual, understandable form. That means an app can dynamically manage many interacting agents, not just a single chatbot. Another standout is how tightly it weaves into a full enterprise ecosystem. Spring AI Alibaba integrates with Alibaba Cloud's model services, RAG, retrieval augmented generation, observability tools like ARMS, prompt management, and MCP, model context protocol, via NACO's registry. This helps take a prototype AI agent and push it into real production environments that already depend on things like config management, distributed routing, and monitoring. The project also powers several higher-level agent platforms. For example, JManus is built on top of it, giving a more general agent system with planning and sub-agent reuse. And Deep Research is a research agent that can search the web, crawl content, run Python tools, and generate reports, all orchestrated via the underlying Spring AI Alibaba graph. It's not just about features, it's about smoothing the path from experiment to scale. Because it's built on the Spring ecosystem, Java developers don't need to relearn how to build apps. They can embed intelligence in familiar architecture. In summary, what sets this tool apart is its seamless blend of agent orchestration, enterprise integration, and developer ergonomics, turning AI from a black box into a composable, production-grade ingredient inside Java applications. Before we jump into the next GitHub project, here's something I've been working on that I know many of you will love, especially if you're into AI design and ad creation. I recently created 100+ AI banner ad prompts for nanoBanana, a complete collection of prompts that can help you generate professional quality, eye-catching banner ads for any brand or business in just seconds. You can use these prompts to design tech ads, fashion visuals, food banners, beauty campaigns, and even creative 3D product shots, all directly inside nanoBanana. And here's the best part. All my YouTube Premium members get this full list completely free. For all my regular viewers, don't worry, you can get access through the link in the description below. These are the same prompts I use for my own AI ad projects, so if you've ever wanted to create scroll-stopping ad visuals, this is the perfect toolkit to start with. Alright, let's get back to our next GitHub project. It's another amazing open-source AI tool you should definitely check out. Project number 2, OpenArm, a fully open-source humanoid arm for physical AI. What makes OpenArm unique isn't just that it's open source, but how it brings together real-world compatibility, safe human interaction, and flexibility for advanced research into one tangible platform. Unlike many robot arms that are either locked behind proprietary systems or too simplistic for serious work, OpenArm is built to inhabit that middle ground, powerful, adaptable, and accessible. At its core, OpenArm is a 7-degree of freedom humanoid arm tailored for contact-rich environments. That means it's designed for tasks where touching, pushing, grasping, or interacting with unpredictable objects matters, a realm where many robotic arms struggle. Because it features high backdrivability and compliance, it can yield to outside forces safely, which is key for both human-robot interaction and delicate manipulation. Another standout is its human-scale proportions and practical payload capacity, not a toy arm restricted to light tasks, but something that can seriously perform within human contexts. What's more, its design is modular and open, with CAD files, parts, and mechanical plans fully released. That lets researchers swap in different motors, end effectors, or tweak geometry to suit unique experiments. Because everything from hardware to control libraries is open, users don't have to reinvent common components, but can build on a cohesive, community-driven foundation. On the software front, OpenArm supports major robotics ecosystems and simulation environments. It integrates with RS2 for control and communication, and works with simulators and frameworks like MuJoCo, MoveIt, Genesis, and more. Finally, OpenArm is engineered for community and collaboration. It invites researchers, hobbyists, and organizations to contribute, adapt, and push the envelope of humanoid manipulation together. Because of all this, OpenArm isn't just another robotic arm. It's a platform that marries practicality, openness, and research readiness in a way few others attempt. Project number 3. nanoGPT, Minimalist and High-Velocity GPT Training Tool. What makes nanoGPT genuinely compelling is how it strips away complexity to leave only the essential, making it ideal for exploration, experimentation, and understanding. Instead of overwhelming users with layers of abstractions, configurations, or frameworks, it offers a minimal, transparent implementation of training and fine-tuning GPT models, so you can see every core concept in clear view. The entire training loop is compact. The model definition is straightforward, and the design encourages you to dive in, modify, and extend. Unlike heavyweight frameworks that try to handle every edge case, nanoGPT embraces simplicity. It makes it easy to train medium-sized GPTs from scratch, or fine-tune existing checkpoints, using only what you really need. No excess scaffolding, just clarity and focus. Because of that, learning, debugging, and customizing become far less intimidating for newcomers and researchers alike. Another standout is how nanoGPT balances efficiency and clarity. Even though it's lean, it remains performant. It can reproduce results on GPT-2 scale models within reasonable compute budgets, while staying readable enough that you can follow its flow end to end. That balance makes it a powerful learning tool. You don't feel lost in abstraction, but also you're not crippled by toy performance. Its openness to hacking is a major differentiator, because every component is laid bare. Data preparation, sampling, context management, you can experiment with novel architectures, tokenization schemes, or learning strategies without fighting through layers of hidden complexity. It also serves as a bridge between toy demos and full production models. Users can begin with small prototypes, understand how all pieces connect, then gradually scale up or plug in more sophisticated modules when needed. That evolutionary path is rare. Many tools either start simple but hit limits quickly, or begin complex and bury you. nanoGPT occupies the sweet spot in between. In summary, nanoGPT's uniqueness lies in its clarity, hackability, and focus on core concepts. It doesn't try to do everything, but what it does with transparency and minimal friction. For anyone wanting to truly grasp how GPT models train and run, this tool is a rare window into the heart of modern language models. Project number 4, LangChain.js, the JavaScript gateway to smarter LLM apps. What makes LangChain.js exceptional is how it stitches together language models, real-world data, and dynamic decision-making under one elegant modular engine. Unlike tools that just wrap a model API, LangChain.js lets you build layered workflows called chains or agents that can reason, call tools, and adapt to context, all in JavaScript. First, LangChain.js gives you a unified interface to different language models, whether you choose OpenAI, Anthropic, or another provider, and lets you swap them without rewriting your entire logic. That flexibility means your application can evolve with advancing models. Second, it introduces tool calling and agents as first-class citizens. The system can decide when it needs to invoke an external tool, for example, a search API or a database query, pass inputs into it, get back structured output, and continue reasoning. That means the AI doesn't just respond, it acts. Third, LangChain.js offers document loaders, embeddings, and retrieval systems built in, so your app can ground its reasoning in your own data. Want to answer user questions about a set of documents or web pages? You don't need to reinvent loading, vectorizing, and searching. They're already part of the toolkit. Fourth, there is a powerful abstraction called the LangChain Expression Language, LCL, which lets you declaratively compose these chains and runnables, route logic, stream results, and build fallback flows without boilerplate. That turns complex workflows into clear, understandable structures. Fifth, LangChain.js is deeply extensible and modular. Every component from prompt templates and memory to custom tools can be replaced or extended. You're building on blocks, not locked in. Lastly, it is web native. Being in JavaScript TypeScript means you can bring advanced LLM logic directly into front-end or full-stack applications without a layer of translation. That smooth path from prototype to production is hard to match. In sum, what sets LangChain.js apart is how it transforms language models from passive responders into orchestrated reasoning systems, able to integrate your data, call external tools, adapt dynamically, and evolve over time, all within the familiar world of JavaScript. Project number 5, HRM, Brain-Inspired Deep Reasoning. What sets HRM apart is how it emulates a layered human-style reasoning process inside a compact model. Instead of relying on giant models or brute force chain-of-thought prompting, it splits the thinking into two complementary layers: a high-level planner that works slowly and abstractly, and a low-level worker that handles fast, detail-oriented steps. These two modules work together without needing explicit supervision of each intermediate reasoning step. Because of this structure, HRM can solve complex problems like hard Sudoku puzzles, mazes, or abstract reasoning tasks with very few training examples and minimal model size. Remarkably, HRM attains such performance using only 27 million parameters, yet it matches or beats much larger models when tested on benchmarks like the Abstraction and Reasoning Corpus, RKE. Another distinctive aspect is that it doesn't depend on chain-of-thought datasets or elaborate supervision of intermediate reasoning traces. Many models try to teach the thinking steps, but HRM skips that. It learns to reason holistically. This makes it more robust and efficient. It also generalizes across tasks without needing large-scale pre-trained models. HRM shows that general-purpose reasoning can arise from architectural design, not only scaling and data. In tasks like optimal pathfinding or solving puzzles, it demonstrates strong results even when given only 1,000 examples. Furthermore, HRM is inspired by how brains operate over multiple timescales: slow, strategic decisions and fast, tactical movements. That inspiration allows it to balance depth of thought with agility, giving it an edge in domains where both planning and execution matter. In essence, HRM stands out because it achieves deep, flexible reasoning within a lean architecture without leaning on huge datasets or elaborate training routines. It bridges the gap between intelligent cognitive structure and resource efficiency, pushing toward more universal AI with thoughtful design rather than brute force scale. Project number 6, RF-DETR, Real-Time Detection and Segmentation Reimagined. What sets RF-DETR apart is how it redefines what real-time means in computer vision, delivering both speed and precision without compromise. It's not just another detection model chasing high accuracy, it's built to push the boundary of usable models in real operational settings. According to its documentation, RF-DETR becomes the first real-time model to surpass 60 AP on the COCO benchmark, a threshold that bridges the gap between research idealism and production viability. Speed is only one side of the coin. Where RF-DETR shines is in combining high throughput with state-of-the-art segmentation capability. Its segmentation variant, RF-DETR Seg in Preview, is claimed to be 3 powers faster and more accurate than the largest YOLO-based segmentation models in COCO benchmarks. That means you can get pixel-level object masks at speeds suited for real environments. Another unique strength is domain adaptability. RF-DETR is evaluated not just on standard benchmarks, but also on RF100VL, a benchmark designed to represent real-world variability and domain shifts. The fact that it performs strongly here suggests it generalizes well to unpredictable contexts beyond curated datasets. What's also remarkable is its efficiency per model size. The architecture is designed to hit the best trade-offs. Smaller variants with lower latency still outperform comparable models across both detection and segmentation. This makes it ideal for edge devices or scenarios where computing resources are limited. On top of that, RF-DETR brings fine-tuning flexibility. You can adapt it to custom datasets while preserving its performance gains, making it a tool not just for publication benchmarks but for real specialized use. In short, RF-DETR is unique because it doesn't force you to choose between speed, accuracy, or adaptability. It reimagines the balance among them and makes advanced vision models more practical for real tasks, delivering sharp detection, refined segmentation, and strong domain generalization, all in a package that's efficient enough for real deployment. Project number 7. Claude Code Templates. Pre-built agents, commands, and integrations for Claude Code environments. This tool stands out because it offers a ready-made ecosystem of components, settings, and workflows built specifically to power Claude Code projects, letting you skip much of the boilerplate and jump straight to creativity and customization. Instead of building every agent, command, integration, or hook from scratch, you can browse and install from a curated library of 100 plus templates that are already designed, tested, and optimized. One unique aspect is how it unifies agents, commands, hooks, settings, MCP integrations, and full project templates into one coherent catalog. With a single tool, you can scaffold a complete Claude code setup, pick an agent like Security Auditor or Front-End Performance Optimizer, mix in commands like Generate Tests or Optimize Bundle, add integrations for GitHub or AWS, and choose configuration defaults, all integrated out of the box. Beyond scaffolding, it also provides monitoring and diagnostics capabilities built in. It includes real-time analytics to observe your Claude sessions, health checks to ensure your configuration remains optimal, and a conversation monitor interface for observing AI interactions securely, even when accessed remotely. Another standout feature is its plugin dashboard and management layer. You don't just get code templates, you get a UI and system for managing which plugins and integrations are active, controlling permissions, and overseeing your custom extensions. That makes evolving and scaling your Claude setup much more structured. What truly elevates this tool is that it treats Claude code ecosystems as living, evolving systems rather than static templates. You can update commands, swap out agents, retrofit integrations, and continuously refine your setup, all with built-in checks and guided defaults. The emphasis on modularity, observability, and composability makes it something more than a starter kit. In summary, Claude Code Template's uniqueness lies in providing a full, structured, battle-tested infrastructure for Claude Code environments, from agents and commands to health, analytics, and plugin governance, so that developers can focus on innovation rather than reinventing recurring scaffolds. Project number 8, Daytona, secure and elastic infrastructure for running AI-generated code. What sets Daytona apart is its elegant combination of security, elasticity, and developer ergonomics when running code produced by AI. Many tools allow you to execute code, but Daytona is built to treat AI-generated code as a first-class citizen, wrapping it in a controlled environment that's both powerful and safe. One standout feature is isolation, with zero risk to your base system. AI models can generate unpredictable or malicious code, but Daytona executes that logic in isolated sandboxes. That means your core applications, infrastructure, and data remain protected, no matter what the AI code does. There is a full separation between user-facing code and host environment. Another unique strength is speed and responsiveness. Daytona spins up sandboxes in under 90 milliseconds. That low latency is crucial when your system needs to interpret, test, or respond to AI workflows in real time. You don't face delays every time you trigger a new code execution. Then there's elastic scaling and parallelism. You can run many AI workflows concurrently, without interference. Daytona's design allows sandbox file systems and memory state to be forked for parallel execution, giving you high throughput for complex AI agent orchestration. Compatibility is thoughtfully handled. You can use standard OCI Docker images for custom execution environments, so you're not forced into a narrow runtime. This flexibility ensures Daytona works with your existing stacks. Finally, Daytona is oriented for programmatic control and automation. You can control sandboxes via APIs for file access, execution flow, Git integration, and language service support (LSP). That means higher-level systems or orchestrators can manage AI logic execution without manual steps. In sum, what makes this project unique is how it treats AI-generated code not as a toy, but as a serious, securable, scalable workload, offering isolation, speed, flexibility, and control in a cohesive package that developers can adopt confidently. Project number 9, Prompt Engineering Guide, your compass for mastering prompts. What sets the Prompt Engineering Guide apart is its sheer breadth, depth, and constant evolution. It's not just a static tutorial, but a living knowledge hub curated by a community deeply embedded in the world of AI. Instead of focusing on one model or one technique, it maps the entire landscape. You'll find sections covering basics, advanced prompting strategies, tool integration, prompt chaining, retrieval-augmented generation, reasoning techniques, risks, evaluation, and even prompt design patterns. This makes it uniquely useful whether you're just starting or pushing the boundaries. Another powerful differentiator is how it brings together many formats in one place: guides, research papers, interactive notebooks, lectures, and real examples. That means you can see not just what works, but the theory, experimentation, and context behind it. It bridges academic research and practical usage, so you don't have to bounce between conference papers and blog posts. Community is baked into its core. Because it's open source under MIT license and welcomes contributions, it stays fresh. New methods, better explanations, new language translations, all can get added by people around the world. The guide evolves organically, reflecting the latest advances in prompt design and in model capabilities. Because it addresses how to think about prompting rather than just what prompt to use, it trains you to handle unseen models and next-generation systems. As models change or new architectures appear, the underlying principles in the guide still apply, making it future resilient. In sum, what makes this project unique is that it's not just a reference, it's a vibrant, evolving ecosystem of prompt knowledge, weaving together theory, practice, community, and foresight, all in one organized, accessible home. Project number 10, MiniMind, lightweight LLM from zero to chat. What sets MiniMind apart is its ambitious goal to let anyone train a full language model from scratch, even with very limited GPU resources and low budget. Unlike most models that demand enormous compute power, MiniMind makes it possible to build a 26 million parameter GPT-style model in just 2 hours on a single GPU, and for an estimated cost of mere dollars. One of its unique strengths is the complete from-scratch implementation. Rather than relying on heavy abstractions or large frameworks, all core algorithms, Toinker, training loops, fine-tuning, distillation, are built using native PyTorch and minimal dependencies. This demystifies how each component works and gives learners a transparent window into the full model lifecycle. Another remarkable feature is MiniMind's ultralight footprint. The smallest model variant is roughly 1/7,000th the size of GPT-3, making it feasible to train and deploy on consumer hardware. Because of this minimal scale, the project encourages experimentation and learning, rather than being locked behind huge infrastructure costs. MiniMind doesn't stop at simple training. It covers end-to-end workflows including pre-training, supervised fine-tuning, LoRa adaptation, model distillation, and even reinforcement learning/preference optimization. That gives users the option to explore the entire path from raw data to a chat model. Furthermore, MiniMind is not just about language, it extends into multimodal vision plus language models under its sibling MiniMind V branch. By combining lightweight visual encoders with its textual core, it supports image understanding in compact form. All of this is wrapped in a spirit of accessibility and learning. The project is as much a tutorial in building small LLMs as it is a usable tool. The clarity of design and focus on minimalism invites anyone curious about how models work under the hood. In short, MiniMind is unique because it brings down the barrier to LLM creation, making it possible to train, experiment, and understand your own language or vision model without needing a cluster or huge budget. We've concluded our step-by-step look at 10 essential game-changing tools. Remember the unique architecture of HRM, achieving deep reasoning with only 27 million parameters and more. If you found your next major tool, hit the like button and subscribe for more deep dives.